Today, I am doing something that I don't usually do, which is to experiment with lighting because I get so many complaints about my videos being terrible quality. And I usually just don't care. I don't really care. I just want to say what I want to say and tell you guys. But this is an important subject. And it's part of my theory of everything. This is actually a stepping stone. It's not a theory, but it's a necessary component for one of the parts of my theory of everything. And something that, like everything else, I didn't really know until I started delving into all of this. So, because it's important, I thought I would try to make the lighting look important. I'm not very good at doing the whole important setup, but I'm trying. But ENTP slouch anyway, which everybody already knows. Which also means you could see the zit on my forehead really well. But whatever. If you guys could see what I was doing for my lighting setup right now. It's funny because when an ENTP just like needs something to work, you just grab whatever. Like you know what the purpose is and you know what you need to do with it, and so you just grab whatever it is. It does not matter what it is as long as the outcome, the effect is what you're looking for. So I'm never gonna tell. I will never tell what I'm using for my light filter right now. So everybody knows what the Big Bang is, right? More or less, pretty much everybody's heard of the Big Bang. The Big Bang Theory television show, or there's like a punk band or something I just found. But the Big Bang, which is per Wikipedia the prevailing cosmological theory on where the universe came from. And basically it says that the universe started as a teeny little speck, basically. A very high temperature, high density little speck. And finally it like burst. Like this little teeny high density speck, like everything you see was all in this tiny little speck of nothingness, like teeny tiny. Something happened that made the bang go boom. Then the universe as we know it spilled out, basically. But obviously it didn't look like that at first. It was just like tons of like gas and shit shooting out all over the place, because it couldn't be matter, because it was too hot, too densely packed and too hot to be matter. And so as the universe expanded all over the place, it cooled. And as it cooled, then the gases, like there was little clumps of gases all over the place. And then as it cooled some more, then the clumps are like bumping and banging into each other. And then as it's cooling, then they start to like gather more compounds of chemicals that eventually reacted, like turn into matter. And then more matter clumps into more matter, and voila, we have the entire universe as we know it. Like the Big Bang Theory says, that's how galaxies were made, how our galaxy was made, little clumps everywhere, pretty much, that just kind of happened to be in just the right place. That is the prevailing theory of where life as we know it came from as well. That theory states that the universe is 13.8 billion years old, and it also states, which is kind of at the beginning of this, but it wouldn't have made a lot of sense. So it also says that take every physical law that you know and like push it to its extreme limit, and that equals singularity. And singularity, they say, is basically like that little speck in the very beginning that the universe hatched out of. Like the singularity is this like little tiny thing where all the physical laws are pushed to their maximum, which I guess is how they can all be condensed into this little teeny tiny speck. It's where like physical laws and science stop making sense. Now my cat has joined me to help me tell this tale. Okay, so starting off, here is just one picture of the Big Bang. 1. The cosmos goes through a super fast inflation, expanding from the size of an atom to that of a grapefruit in a tiny fraction of a second. 2. Post-inflation, the universe is a seething hot soup of electrons, quarks, and other particles. 3. A rapidly cooling cosmos permits quarks to clump into protons and neutrons. And now we're finally at 1 second. 4, still too hot to form into atoms. Charged electrons and protons prevent light from shining. The universe is a super hot fog. So then for about another, that happens for another 3 minutes. And then 5, electrons combine with protons and neutrons to form atoms, mostly hydrogen and helium. Light can finally shine. And that happens for about 300,000 years. Then for 1 billion years, gravity makes hydrogen and helium gas coalesce to form the giant clouds that will become galaxies. Smaller clumps of gas collapse to form the first stars. And for 15 billion years to the present day, as galaxies cluster together under gravity, the first stars die and spew heavy elements into space. These will eventually form into new stars and planets. This is who I would like to introduce you to. Now I will butcher his name. I'm going to call him George, but just so you know how it's supposed to be,
Georges Lemaître.
That's how his name should be pronounced. I will not even going to try. He was born in Belgium in 1894, and he lived to be a ripe old age of, 72. I just had to do that. I had to do it on my fingers. He obtained his bachelor's in philosophy, a BA and PhD in mathematics, PhD in physics from MIT. He was an ordained Catholic priest, and that happened in 1923 when he was only, somebody needs to be here to do math for me. He was 29 years old. Phew, got it. He was also a World War I veteran in the Belgian army. So now we're skipping to Albert Einstein, right quick. Albert Einstein leaves Germany, 1933. As soon as Adolf Hitler was granted German citizenship and began to take power and spread his Nazi anti-Semitic ideas, the German Jewish physicist Albert Einstein took a stand against Nazism and quickly took action to leave Germany. Einstein helped to organize a nonpartisan group that stood united against fascism. Einstein, his family, and his secretary left Germany, and in March 1933 he renounced his German citizenship, declared his resignation from the Prussian Academy of Sciences, quickly separated himself from all German institutions that he worked with, and announced that he would not return to Germany. Einstein stood against the Nazi regime and declared, as he and his family moved to the United States of America in 1933, "I shall live in a land where political freedom, tolerance, and equality of all citizens reign." I don't know about you, but I already loved Einstein, and finding that out about him, especially that quote, it's so amazing, just made me love him way more. He's definitely an ENTP hero, which is another video that I'm going to make sometime soon. Now you're probably wondering, okay, so now we've got this Catholic priest, and we've got Einstein. What are you talking about, ENTP? But as you know, ENTPs must build their cases. And also, I read a really awesome article in Gizmodo, which I will link to the bottom, but this storyline is following that article in many ways. I am using their format with pictures and a lot more words. This is Einstein leaving Germany, and what many people do not know is that on that very same train was Georges Lemaître. That's about as close as I'll get. I shouldn't try that again. They left Germany together. We already know that George is a brilliant guy with all of his many, many accomplishments here. As a pretty young man, he wrote something called, I'm not even going to try to pronounce that, but it translates in English to the primeval atom, a hypothesis of the origin of the universe. George came up with a profound theory that still impacts our study of the universe today. In 1927, he published his article, "A Homogeneous Universe of Constant Mass and Increasing Radius, Accounting for the Radial Velocity of Extragalactic Nebulae," or his theory of an expanding universe. What he did was that he used Einstein's theory of relativity as his guide, and he speculated that space is constantly expanding, and therefore the distance between galaxies is also increasing. Later, Hubble would demonstrate the same thing, and even to this day is generally given credit for coming up with the idea. Further, Lemaitre discovered what has since become known as Hubble's law. a rate of expansion related to the galaxy's distance from Earth. George also derived what is now known as Hubble's constant. In both of these instances, he did this before Hubble published his work concerning these same revolutionary ideas. Hubble's real contribution in this case was to provide the observational basis for George's mostly mathematically based theory. Unfortunately for George, his Nobel Prize-worthy paper, though at the time astronomers couldn't win the Nobel Prize for their work in astronomy as it wasn't yet considered part of physics, had little impact on the scientific community due to it being published in a journal hardly read outside of Belgium. But one man in particular read it: Albert Einstein. George and Einstein met for the first time in 1927 at the famed Fifth Solvay Conference in Brussels. Impressed with George's findings, but not swayed, he told him, "Your calculations are correct, but your physics are abominable." Essentially, Einstein thought George's math was correct, but what the math seemed to show was not. In 1931, wishing to make his theories more widely read, George sent his article to Sir Arthur Eddington, a British astrophysicist and someone who wanted to make scientific theories accessible to everyone. He was the one who announced and helped explain to the English-speaking world Einstein's theory of relativity, when he was still a German-based scientist. Eddington translated George's work and had it published in the monthly notices of the Royal Astronomical Society, a peer-reviewed journal still in existence today. After this publishing, it became apparent to both skeptics and George himself that there was something missing from his theory. The universe is continuously expanding, but when and how did the expansion begin? This left George perplexed, but like a good scientist, he kept questioning. Only a few months later, using Eddington's 1931 talk about the end of the universe entitled "On the End of the World from the Standpoint of Mathematical Physics" as a guide, George came up with another groundbreaking theory. In a May 9th, 1931 letter to Nature Journal, also still published today and has been since 1869, George wrote, "If the world has begun with a single quantum, the notions of space and time would altogether fail to have any meaning at the beginning. They would only begin to have a sensible meaning when the original quantum had been divided into a sufficient number of quanta. If this suggestion is correct, the beginning of the world happened a little before the beginning of space and time." This would be coined later in a collection of essays in 1950 by George as the primeval atom, where he would also refer to the beginning as a now without yesterday, or mistranslated and more popularly known as the day without yesterday. This was the foundation of what would become known as the Big Bang Theory, after several other scientists would add to George's theory. So, the Big Bang Theory actually was actually a name given in a way to make fun of him by another scientist, Frederick Hoyle. Hoyle said, "The Big Bang is an irrational process that cannot be described in scientific terms, nor challenged by an appeal to observation." He was just like, "Oh yeah, look at this guy with his Big Bang Theory." That's pretty much what he called the primeval atom and the expanding universe. He was just like, whatever, yeah, okay, Big Bang. So that's where all of the cosmology and everything and blah, blah, blah. It all came from one dude just like making fun of our dear friend George here. One of the reasons that Hoyle was so hell-bent on making fun of this theory at the time, before all of the other things that science has added to it, to have a Big Bang implied that there must be a creator. Whereas a steady state universe, which was Hoyle's, which I will describe a little bit in a minute, it didn't need a creator. There were many skeptics of this time that did not agree with this origin theory. They believed that George's religious background clouded his scientific process. Essentially, what George was claiming, according to critics, was that something somehow had to have created the primeval atom, leaving open the possibility of a greater being. You see in front of you Tommy Gold, Herman Bondi, and Fred Hoyle, who were the three most well-known and biggest critics of The Big Bang Theory. Hoyle met Bondi and Gold in 1942 when he was assigned to a radar station erected to warn of bombing attacks on London. Over the years, the three spent many evenings discussing physics together. Like Einstein, they were unhappy with the idea implied by Hubble's observations that the universe is expanding. They came up with the steady state theory one evening after watching a movie together. Since they could not argue effectively with the evidence provided by Hubble's observations, the puzzle they had to solve was to explain how the universe could be expanding while still staying the same. The movie they saw together was a British horror film called The Dead of Night. The central character of the story wakes up from a nightmare only to find that the experiences from his dream are real. In the midst of the mayhem, he wakes up relieved to find that it was all a dream. Later in the day, the experiences from the dream start to happen again in real life. In other words, the story evolves over time, but ends up exactly where it started. Many modern movies, such as the comedy Groundhog Day, have since been written with this general structure. Tommy Gold's idea, inspired by the movie they saw, was that as the universe expanded, new matter was created in the widening gaps between the galaxies. The idea that the universe is always changing yet remains the same is called dynamic equilibrium. Although the theory does not explain how matter could be created from nothing, the same criticism could be leveled at the Big Bang Theory. The two competing theories were now established. The Big Bang Theory predicted that the universe is expanding from a single point and that the remnants of the Big Bang could be observed in the form of microwaves. The steady state theory proposed that although the universe is expanding, new matter is always being created so that the average density of matter in the universe does not change. The rate of matter creation needed 10 to the negative 9 atoms, blah, 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 was very small and could not be ruled out experimentally. The steady state theory predicted that no microwave signal would be observed. But neither theory was perfect. Add insult to injury as far as George was concerned, the Pope at the time got behind it, just wholeheartedly endorsed it. And let's see, he said, Pope Pius the Seventh proclaimed in 1952 that the Big Bang Theory affirmed the notion of a transcendental creator and therefore was in harmony with Catholic dogma. And George was not about that. Even though he was obviously, he's Catholic, he's a priest, he believes in, God, but he did not want the Pope to endorse it. He believed that the science could stand on its own. He was, very serious about his science. And I'm sure another part of the reason was that anything that might have God behind it, he knew that it would have been completely rejected by the scientific community. It made him just be like, what can you really say to the Pope? Basically, the Pope was delighted. The Pope was super stoked about it. The Pope was stoked. But I read that he didn't bring it up again after this big huge speech that he gave, or not very much, and I'm guessing it's probably out of a favor to George, who wanted to be taken seriously for his math and his ideas. Ironically, given that George's math and theories were generally sound, given the state of scientific knowledge of the day, in many of these cases it was the dissenting scientists allowing their own biases to influence their perception of George's work. How often have we heard that? That's pretty much standard for science, just so everybody knows. Scientists are just as susceptible and promoting of ideology as anyone else about anything else. It does not matter if it's science. People that are ideologically committed for billions of reasons to a certain theory being true are going to fight tooth and nail to hold on to it, to prove that it's true, to do whatever they have to sue, to shout, to scream, to burn. The people that are the truth tellers are often few and far between. They either have nothing to lose, they don't care, they don't have jobs to lose, they don't have professorships to lose, they don't care if their name gets trampled in the scientific community. But it is very, very rare and few and far between for genuine academics, scientists, very brilliant people. There are not tons of people that want to stand up and fly in the face of whatever it is that science is saying right now, because whatever it is that science is saying right now is almost guaranteed, at least in our world, it is trying to find any explanation for anything other than God, right? So if you find something that might give a little bit of credit to an idea that it could be God, then you have to be one of those people who does not mind being on their couch on the outside of society, of scientific society, and that's a lot to lose because you will get blackballed. And another one of my ENTP heroes is exactly that person. I can't wait to talk about him. And I'm not saying, I'm not bashing science. I'm saying science is just as ideological as the Catholic Church. It's freaking true. All right. Despite the conflict between all the competing ideas, George detailed his theories to an awe-inspired audience in 1933 at the aforementioned conference in Pasadena, California. When he was finished, Einstein proclaimed his now famous quote, "This is the most beautiful and satisfactory explanation of creation to which I have ever listened." New York Times writer Duncan Aikman, who was covering the conference, took a picture of the two scientists together with the caption, "They have a profound respect and admiration for each other." In the same article, Aikman continued, "There is no conflict between religion and science," George has been telling audiences over and over again in this country. His view is interesting and important, not because he is a Catholic priest, not because he is one of the leading mathematical physicists of our time, but because he is both. And that about wraps up what you know about the Big Bang. You guys know this about the father of the Big Bang, as he is very often called, because I didn't. I heard it in passing in my studies when I started this a while ago, but then I just didn't really look into it. And so, because I want to get back into the theory of everything again, I had to research it, and it has a lot to do with some parts that I have coming up. What do you think about that? And I guess we're now on to the point where I say, if you want to figure out what you think about it, then and you don't want to hear what I think about it, then you should probably turn this off now. If you want to hear my thoughts on it, however, and you're not tired of my voice yet, or you're just curious, so you're just going to put up with it, then I will tell you now. Many great scientists, inventors, astronomers, the theorists and the mathematicians in history were believers. They believed in God. They believed in a greater being. And I think it's really easy to write this off to, oh, it was just in the past. They just didn't know any better. They were always needing to have things explained by the gods and this and that. I think that's pretty much the standard reason that people give. The reason that I find the most compelling, and that makes perfect sense to me, is the one that George actually said himself. And I was so delighted to see this quote that he gave because it is also what I believe about why so many of the great minds were believers. Both of them, the scientist believer and the scientist non-believer, attempt at decoding the palimpsest, I don't know what that word is, of nature. Hang on. What does that mean? Palimpsest, a manuscript or piece of writing material on which the original writing has been effaced to make room for later writing, but of which traces remain. Wow, what a fascinating word. I'm going to have to use that one. Palimpsest. Oh, I had that all wrong. Palimpsest. Okay, let's get back to it. Both of them, the scientist believer and the scientist non believer, attempt at decoding the palimpsest of nature with multiple imbrications in which the traces of the various stages of the world's lengthy evolution has been overlapped and blended. The believer perhaps has an advantage of knowing that the riddle possesses a solution, that the underlying writing finally comes from an intelligent being, and consequently that the problem proposed by nature has been posed in order to be solved. Therefore, that its degree of difficulty is presumably measurable with the present and future capacities of humanity. Is that not the best answer ever? and most eloquent and most like, dang, the vocabulary on that guy. Woo! I'm in awe of that. Those are only three sentences. I'm like, I think there was at least 2 words I've never even heard of. Obviously, that was a smart dude. Besides everything else I just talked about, I'm like, wow, it's vocabulary. He's a smart cookie. And I agree with him. So many of the great discoveries and theories to explain our world were created by people who were confident that they would find answers. They were confident that that our surroundings weren't random. That it wasn't just like, oh, who knows why we're here. They knew that as long as the harder they work, the closer they would get to understanding the world around us, because God is understandable, and God is a conscious being, and it's where our consciousness comes from. A lot of the time they know it's just a matter of technology, and maybe it isn't something that they're going to figure out in their lifetime, but they knew that the answers are all around us because God makes sense. we were made to understand and to find the answers in the world around us. Our sense, our common sense, our rationality comes from God. We are made in God's image, and that's why. They didn't just look around them and think, okay, this is just a bunch of randomness. They looked around them looking for patterns, looking for equations, looking for artifacts, looking into the stars and expecting to find an explanation, a reason, a reason that everything around us is here at all. So because they were looking for it and because that confidence was there, that's why they found it. That's why we have the basis of science, period. You know, it was built in the minds mostly of men who believed in a higher power and believed that it was there for a reason and that they had the capability, the God-given conscious mind to be able to figure it out. So I think that's everything. That is it really just a history lesson for today. And so my theory, I don't know yet if I'm going to stick with the cosmos or if I'm going to come back to Earth for my next video. But this this history lesson was necessary for the part of my theory that, well, there's a couple parts that are going to end up in the stars. So thank you for joining me to learn about George and Einstein, and I'd love to know what you think of that and how many of you knew that, or if it's your first time hearing it, like it was for me. Good night, everyone.